Hi, 7th grade. Welcome to lesson 7.5, Determine Outcomes of Compound Events. By the end of the lesson, I want you to be able to say, I can find all possible outcomes of a compound event. Let's solve and discuss it. Cameron packed 2 pairs of shorts and 3 t-shirts for a weekend trip. What are some combinations of shirts and shorts that Cameron can wear while on his trip? How many days will he have a different outfit to wear? Okay, I'm going to take some participation and hopefully we get some responses. Okay, so I was thinking he could do the yellow shirt with the green pants, or he could do the yellow shirt with the blue pants. And then we could repeat that with the white shirt. You could do white shirt with the green pants, or the white shirt with the blue pants, and last but not least, the red shirt with the green pants, Merry Christmas, or the red shirt with the blue pants. So there's 6 different combinations. Focus on math practices. How would the number of different outfits change if Cameron packed a pair of khaki shorts? Explain. Well, he'd have a different pair of shorts to wear with each shirt, so there would be 3 more options. And if you notice, before we had 3 shirts times 2 pants, and that gave us 6 options. Now, if we have 3 shirts and add that extra pair of pants, so times 3 pants, now there's 9 options. Example number 1. Find all the possible outcomes. Haley has 2 sisters and no brothers. Josh has 2 brothers and no sisters. They wonder what the chances are in a family. With 3 children that the children will be all boys or all girls. How can they determine all the possible combinations of boys and girls with a family of 3 children? So the different events is that child 1 is either a boy or a girl, child 2 is either a boy or girl, or child 3 is either a boy or girl. This is a compound event. A compound event consists of 2 or more events. This compound event consists of 3 events. So the first event happens, and it could be either a boy or a girl. So this is the first event. If there's a boy, it doesn't matter that the first child is a boy. The chance of the second child could either be a boy or a girl. So then it branches down, and then same thing, the third child could be a boy or a girl. So we wanted to know these were all the possible combinations. There's 1, 2, 3, 4, 5, 6, 7, 8 possible combinations. Haley and Josh can make a tree diagram to show the sample space of boys and girls in a family with 3 children. Try it. Jorge will flip 2 quarters at the same time. Complete the tree diagram, then list the sample space of this compound event. Use H for heads and T for tails. So flipping the first quarter, you could either get a head or tails. Then when you flip the second quarter, if you flip the first quarter and got a heads, the second quarter could be a heads or a tails. Or if you flip the tails, you could get a heads or tails. So there are 4 possible options. We could get heads and heads. We could get heads and then tails. We could get tails and then heads. Or we could get tails and then tails. So those are 4 possible options. So remember, writing the sample space, we have to use our curly brackets. So we've got 2 heads and a tails and then heads, and tails and tails. How does the sample space change when the number of quarters that Jorge flips is increased by 1? Well, if he flips another quarter, then we're going to have 8. So quarter 3 would have 8 options because we branch off again twice for everyone. If he flips 4 quarters, we're going to have 16. So each time you multiply by 2, which makes sense because there's 2 options, heads and tails. Example number 2. Use a table to represent sample spaces. This is kind of like a big Punnett square like you're learning in science. A game is played by spinning 2 spinners shown. Players match the results of the spinners to combinations on their game cards. How many different combinations are possible? Use a table to represent the sample space. Remember, the sample space shows all the possible outcomes. So the first spinner, you could get 1, 2, 3, or 4. Second spinner, you could get A, B, C, D, E, F, G. Or sorry, just E, F. So then when you match them up, you say, okay, A in 1, B, you just match up and down. So 36 different letter number combinations. The sample space consists of 36 different outcomes. Use an organized list to represent sample space. Stan will roll a number cube labeled 1 through 6 and flip a coin. What are all the possible outcomes? Use an organized list to represent the sample space. Notice that they still have the curly brackets. So if he rolls a 1 on the die, he could either roll heads or tails. If he rolls a 2 on the die, he could get heads or tails. 3 on the die, he gets heads or tails. 4 on the die, he gets heads or tails. 5 heads or tails, or 6 heads or tails. So there's 6 possible outcomes for the dice and 2 possible outcomes for the quarter. So when we multiply that, you get 12 possible outcomes, which makes sense because the sample space consists of 12 possible outcomes. So there's a good way to check. The bag contains tiles labeled with the letters A, B, and C, and the box contains tiles labeled with the numbers 1, 2, and 3. June draws 1 letter tile and 1 number tile. Represent the sample space using either a table or an organized list. We're going to do both. But in the bag with the letters, there's 3 options, and the bag with the numbers, there's 3 options. Multiplying those, I should already know that I'm going to have a sample space with 9 possible outcomes. So first we can do a table. And on the table, we're going to do A, B, and C are our outcomes for the letters, and 1, 2, and 3. So we make our table. So we could get A1, we could get B1, and we could get C1. We could get A2, B2, C2. We could get A3, B3, or C3. And in the magenta, there's all of our possible outcomes. The way it looks in a list, remember we need our curly brackets. And we would have, okay, you pick an A, you could pick a 1. You pick a B, you could pick a 1. You pick a C, you could pick a 1 with that C. Then you could pick A2, B2, C2, A3, B3, C3. So they're the same outcomes that were in our table, but now just listed in a list. Key concept, I didn't put in. So let's say it. I can find all possible outcomes of a compound event. Have a great day.